In problem 5b, we're given the polynomial 2x cubed minus 7x squared minus 3x plus 8, and we're asked to find all of the roots algebraically in simplest radical form, and then we're going to sketch the complete graph indicating the viewing window, x-intercepts, and the relative maximum and minimum. Well, let's start by finding all the roots algebraically. And in order to do that, I'm going to look at this and I'm going to try to see if there's anything that I can do to factor it. And there's nothing that really jumps out at me as a way to factor this. I can't pull anything out. It doesn't look like it's going to factor by grouping. So even though I'm going to want to find my roots algebraically, what I'm going to do is I'm going to first go to the graphing calculator just to see if looking at the graph can help me identify one of the roots, so that if I can figure out a root based on the graph, then I can go back and I can show that it's a root algebraically. But I'm going to use the graphing calculator just to try to push me in the right direction. All right, so going over to the graphing calculator, you can follow what I'm doing here. You can watch my cursor, and any button that I press will turn red, so you can see what I'm pressing. And then you can see a larger screen here. So the first thing I need to do is put in my equation. So I'm going to go to y equals, and I have to put in 2x cubed. So 2, and then the x button is here. It says x, t, theta, n, but it's being used as an x. And then to cube, I have to use this cursor button to tell, this caret button, sorry, to tell me that I want to go up in the exponent. And it's going to be 3. And then notice my cursor is still up here in the exponent. If I were to start typing, right, I'd still be up in the exponent. So I'm going to go back and delete that. So before I put in the rest, I need to get out of the exponent. And I'm going to do that by pressing the forward button. So then I'm going to keep going. Minus 7. For x squared, I can do the same thing with this caret, or I can hit the squared button. Minus 3x plus 8. And my goal is to figure out if there is an integer root that I can use to get myself started. Okay, so meaning if there's a, right, so I'm going to place where the graph intersects the x-axis, that's an integer value. It'll just be a little bit easier if I have an integer. So looking at the graph, this one's for sure doesn't look like going through an integer value, because this is between 1, 2, 3, it's somewhere between 4 and 5. This looks like it probably could go through 1. This one maybe goes through -1, maybe not. Now, you could use a trace to try to figure out a little bit more exactly, but it's not the best way to do it. The best way to do it is to actually go to your table. So I'm going to hit second table. And what I'm really interested in is knowing if it goes through 1, 0 and -1, 0. So I'm seeing here, so this is what I want you to focus on right here. So this second row here. It does when x is 1, y is 0. So if we're trying to find a root, what we look at is this y column and see if there's a 0 here. And if you have a 0 here, you say, oh, look, x is a root, because when x is 1, y is 0. And then if we just want to check -1, because we thought from our graph that might have been, and look, it's not. It doesn't go through -1, 0. When x is -1, y is 2. Okay, but all we needed was one root to get us started, and we got it, right? So when x is 1, y is 0. So x equals 1 is 1 root. And then we can go and we can do long division to find the other ones. So now that I know that x equals 1 is a root, what that tells me is that x minus 1 is a factor. So let's see what happens when we divide x minus 1 into 2x cubed minus 7x squared minus 3x plus 8. So I'll set up my long division like this, with x minus 1 on the outside, and then on the inside I have my 2x cubed minus 7x squared minus 3x plus 8. So now when I do this long division, I just look at the highest degree terms. So I only look at the 2x cubed for right now and the x. And the question I want to ask myself is, what do I have to multiply x by to get to 2x cubed? And the answer to that is I could multiply by 2x squared. Right? X times 2x squared is 2x cubed. So what I'm going to do is I'm going to put that above my bar, and I'm going to put that in the x squared column. So here you see an x squared. So I'm going to put my 2x squared above that. So 2x squared goes right there. So now what I do is I take this 2x squared and I multiply it by x minus 1. And actually, let me put parentheses around this x minus 1 just to be really clear that we are taking the 2x squared and we're multiplying it by the entire x minus 1. And then whatever I get gets subtracted. So 2x squared minus x, so doing my first term, is going to give me 2x cubed. And then 2x squared times negative 1 is minus 2x squared. Okay, so now I need to subtract. So first 2x cubed minus 2x cubed, those are going to cancel. Okay, and now what I have over here is 7x squared, and then this is minus negative 2x squared. So it's really 7x squared plus 2x squared, so it's negative 5x squared. So now what I'm going to do is I'm going to bring down these last terms that I haven't used yet. I'm going to go through the whole thing again. So now I'm going to again look at the highest degree term of what's left, which is this negative 5x squared, the highest degree term here. And I have to ask myself, what do I have to multiply x by to get negative 5x squared? So highest degree term here, highest degree term here. And the answer is that I'd have to multiply by negative 5x. And again, I'm putting this over my x column. Okay, so negative 5x times x would give me my negative 5x squared. So now what I have to do is I have to multiply my negative 5x by my whole x minus 1. So I'm going to get, and I'm going to subtract all of that. So negative 5x times x is going to be negative 5x squared. And then negative 5x times negative 1, I have a negative times a negative, so it becomes plus 5x. Now I'm going to subtract. So this is going to be negative 5x minus negative 5x. So negative 5x plus 5x. And then over here, this is going to be negative 3x and then minus 5x. So it actually becomes negative 8x, and then pull down this, plus 8. So now again, looking at my highest degree term here, which is negative 8x, highest degree term here is x. What do I have to multiply x by to get negative 8x? Well, I would have to multiply by negative 8. So I put that in right here, just right above my constants. And then I do the same thing. I multiply this negative 8 by this x minus 1, and I subtract. So I'm going to get minus negative 8 times x is negative 8x. Negative 8 times negative 1 is plus 8. So now when I subtract, so this is going to be negative 8x plus 8x. Those are going to cancel. This is going to be 8 minus 8. Those are going to cancel. So my remainder is just 0. And this is what we expected, because the whole reason we started with this x minus 1 being a factor is that we saw that on the graph, and we expected this to come out to be 0 because we thought this was going to be a factor, and now we just know what the other factor is. So what this tells us is that f of x, which we know is 2x cubed minus 7x squared minus 3x plus 8, also factors into, you can write f of x as x minus 1 times 2x squared minus 5x minus 8, where again, the x minus 1 comes from right here, and the 2x squared minus 5x minus 8 is what we found up here. So what this whole long division tells us is that this times this equals this. So since this one is f of x, right, this one times this one is a factored version of f of x. Okay, so now we have f of x is equal to x minus 1 times 2x squared minus 5x minus 8. But what we're looking for is all of the roots. So really, we still only have this one root, but now at least we have a quadratic, and so we have to figure out if we can get some roots out of here. I look at it, I don't see off the bat any way that I can factor it easily, so I'm going to go ahead and use the quadratic formula for that. So in order to use the quadratic formula for this, what I'm going to notice is that I'm going to have a equals 2, b equals -5, and c equals -8. And then I'll go ahead and plug into the quadratic formula. Quadratic formula tells me that x equals -b, so -5, plus or minus the square root of b squared, so -5 squared, minus 4a, which is 2, times c, times -8, all over 2a. So 2 times 2. So simplifying this a little bit, I get x equals, so -5 is +5, plus or minus the square root of -5 squared is 25, and then -4 times 2 times -8. I have two negatives, so this is going to be plus, and then 4 times 2 is 8, times another 8 is 64, and that's all over 4. So then we get x equals 5 plus or minus the square root of 25 plus 64 is 89, all over 4. So therefore, the three final roots are x equals 1, which I got from this factor right here, x equals 5 plus the square root of 89 over 4, and x equals 5 minus the square root of 89 over 4. So there are our three roots, and we did find them algebraically using long division and the quadratic formula. But now we want to sketch the complete graph indicating the viewing window, x-intercepts, and the relative maximum and minimum, and we can do that part on a graphing calculator. Okay, so now let's go back to our graph. We already have it entered into the calculator. And if we go to the graph, okay, so here you can see, here are the intercepts. Here's our x equals 1. Here is at 5 plus square root of 89 over 4, 5 minus square root of 89 over 4. Notice my viewing window is not quite right because I'm missing this minimum right here, and I have too much space in the x direction. So let's actually start by adjusting that. Let's do the x first. I probably only need to go from -5 to 5, so I'm going to click Window. So I'm going to put in, instead of -10, -5, making sure that I hit this negative button down here, not the subtract button. So -5 and 5 on the x. Let me just quickly go back to the graph just to make sure that that looks good on the x direction. I know I'm still going to be cutting things off in the y direction. Okay, that looks good. And I can see I need a little bit more space in the y direction, especially in the negative y direction. This looks okay, but maybe I'll adjust my y minimum. Right now I'm at 10, so maybe I'll make it down to 15, just to give myself a little bit more space there. So let's go back down to the y minimum. Okay, so here's my y min. Oops, I went too far. My y minimum tells me the smallest y can be, just like with x, right? I went from -5 to 5. Y minimum, I want to go, let's start at -15. Okay, let's see how that looks on the graph. Okay, so this looks much better. Right? We have a nice picture of what's going on here. So now I want to find the maximum. So we already found the x-intercepts, right, which we found algebraically, right? We started with this x equals 1, and then we had already, we can make sure that this is 5 plus square root of 9, 84 over 84, sorry, 5 plus the square root of 89 over 4, and 5 minus the square root of 89 over 4. So now let's just find this minimum and this maximum, sorry, this is a maximum because it's greater than everything around it, and this minimum. And we can do that by going second calc, okay? And let's do the maximum first. So let's go down to 4, okay? And I hit enter. I also could fit 4 here, but okay. And what I'm going to do is, so notice this one's a maximum because this point is kind of the top of the hill. It's bigger than the stuff around it. And so it's saying left bound. So what I want to do is I want to move my cursor so it's slightly to the left of my maximum. And I can hit enter. Okay. And now it's saying right bound. So I'm using, again, my arrow keys to move my little trace button so it's to the right. Anywhere to the right. Enter. And so now you can see these arrows, it's just kind of telling me you're trying to find a maximum that's somewhere between these two arrows, and then it's asking you for a guess. So I'm just going to move it somewhere, it doesn't need to be perfect, right near that top. Okay, and it tells me that this maximum point happens at an x value of negative 0.1975603, and the maximum value, right, the y value is 8.3040488. Okay, so that's my maximum. All right, now let's do the same thing to find this minimum down here. So I'm going to go second calc, right? See where it says calc right above trace. So before I kind of use the arrows down, you can do that, or I'll just show you can also hit, for minimum, it's number 3. So I'm just going to hit 3. Okay, so now it's asking me left bound. So let's go a little bit closer. Okay, but you don't need to go so close. Even you know, doesn't matter. Here, this is right here's the minimum I'm looking for. My cursor is to the left of it. So I'm going to hit enter just to tell you, okay, yeah, my cursor is to the left of the minimum, right? As long as you don't include, you know, the maximum in there, you should be okay. If you want to get closer, you can. But now it's asking me for right bound, so I have to move until I am to the right of that minimum value. So I'm going to keep moving. There you go. Okay, oh, I clicked. Oh, all right, it was a little behind me. All right, but that's fine. To the right, enter. I didn't need to go that far, but I did. And now it's asking for a guess. So let me move back. I'm not going to click so many times. It doesn't need to be a perfect guess. See, I'm a little bit off, but that's okay. It's really okay if you do an imperfect guess. Okay, and it tells you the minimum is at x equals 2.530878917, and the y is at negative 12.00775. Okay, so there we have our graph, our minimum, maximum. We found the x-intercept algebraically.